The broadcast is now starting. All attendees are in listen-only mode.
Well, good morning, everybody, and welcome to today's session from Smart Vision Europe. And this is one of a series of webinars that we regularly run. So we're doing 3 web sessions today, and the first one we're dealing with is about IBM SPSS Statistics, which is, of course, a popular stats tool. My name's Charles Quinn. I'm an analytics consultant here at Smart Vision Europe, and I'm joined online today by my colleague Rachel. And Rachel will be making sure that everybody's logged in correctly and fielding questions as we're going along. If you haven't joined any of these sessions before, then there's just a few housekeeping things that we normally deal with. First of all, that these sessions are recorded. They normally last between about 45 minutes to an hour. We do send out a copy of the slides to you afterwards. There aren't very many slides here. There's just a few positioning slides and context slides. But we email out a PDF copy to you after the session's ended. If you think it's particularly useful for your colleagues, it may be possible for us to arrange a rerun for it. So, if you want a private session, we might be able to do that. So just send us an email or ask us through the chat facility to do so, and we'll see if we can schedule the time to do that. And with regard to asking questions, well, all the lines are muted. So unfortunately, you'll need to use the chat facility. And if we can't answer them as we're going along, obviously we'll follow up with you afterwards if we run out of time. So just without spending too much time on who we are, etc., just again, if you don't know who Smart Vision are, if you're not aware of us, we're a technology organization, and we are a partner to organizations such as IBM and SAS. If you've heard of SAS, we're a big analytics company, and also a company called Predictive Solutions. We provide services and software around those organizations and around their products. So we also work with open source technologies, R, Python, Spark, etc. And we're made up of a team of people who all are veterans of the analytics industry. We all have about 15 to 25 years of experience working in advanced and predictive analytics. And with regard to the sorts of sectors we work in, well, we don't specialize in any particular sectors, but we have a lot of experience in the application of advanced analytics, for example, within retail or gaming or utilities, insurance organizations, telecommunications, charities, media, and FMCG, and many other sectors as well. Okay, so today we're going to be talking about SPSS Statistics, and we're going to be taking you through an end-to-end process of using the software and how it works, and showing you a number of procedures which we think are quite useful. But if you've already got the software, if you're thinking about getting software like this, then these are the sort of typical things that one would be working with software like SPSS Statistics. So this would be, bringing data in. The data, of course, may be in a third-party format. It may be in a database, it may be in a flat file, maybe in a spreadsheet format. Formatting the data within SPSS, that means setting it up in such a way that SPSS, you're getting the best out of the data, and the SPSS likes the way in which you're presenting the data. And then, creating filters within data, or creating new fields, banded fields, using the SPSS tables functionality to create publication quality reports, and finding statistically significant differences in groups, as well as a number of other procedures that we'll be looking at, including charts, etc. So just let's begin with an overview of IBM SPSS Statistics, just so you're aware of it. So SPSS Statistics, or SPSS as it's more commonly known, is one of the world's most popular data analysis and statistical interrogation platforms. It's been around since 1968, so it's got quite a deep pedigree in software terms. And it's used for everything from epidemiology to survey research to business reporting, direct marketing, credit risk, predictive modeling, and predictive maintenance, like asset management type applications. So the point here is that it's very difficult to talk about a typical user of SPSS Statistics. There are many, many different users of it, in the same way that it's very difficult to talk about a typical user of a spreadsheet package such as Excel. It's used very, very broadly. But the sorts of things that you would expect to get in a standard sort of base version of SPSS Statistics are a bunch of descriptive statistics, such as crosstabs, frequencies, descriptive statistics, such as means, medians, that type of stuff, measures of central tendency, as well as a raft of statistical testing capabilities, such as chi-square, or t-tests, or ANOVA, or correlation values, predictive algorithms such as linear regression, and also things like factor analysis and cluster analysis, multivariate techniques. There's actually quite a lot of different analytical procedures within the base copy. If you don't know what I mean by the base copy, you should be aware that SPSS is a modular system, which reflects the fact that not everybody uses it in the same way. These modules are purchased separately from the base, or they purchase sometimes at the same time, and they enhance the functionality. So the modules that you can see listed in front of you, it's pretty much the full number of modules that you could install into SPSS base. If you wanted to know how these would appear, they would appear as additional menu items or additional dialog boxes within SPSS. So it's pretty seamlessly integrated. And very often a very common question that people ask is about how they can identify what modules they've got installed within SPSS. And if you look at our website, there's information about how you can do that. But there are typical sorts of modules you would get are things like advanced statistics, which includes a number of multivariate procedures from the ANOVA or generalized linear modeling family. It's used a lot within things like insurance and within experimental research. Or you have things like forecasting for people who want to do time series analysis, or complex samples, which for people who wish to create statistics or analyze data that takes into consideration the fact that the data wasn't drawn from a random sample, but was in fact drawn from a very complicated sample, and so on and so on. Just so that you're aware, on our website, you should find that if you go and look these modules up, there is a little somewhere between 2 and 3 minute video each, so not a very long video, that explains what each module does and shows you some screenshots of how they're working and maybe a little demonstration there. So all less than about a 2 minute overview of each of these different modules, which is quite useful if you've always wondered what they are, if you're a little bit curious about what they do. Okay, just so you're aware that there are various packages that IBM provide these modules in, or provide SPSS statistics in. So you can, of course, just have a base version, but a typical package would be something like the IBM SPSS Statistics standard package, which is tables, advanced statistics, and regression module, or the professional package, which includes a few more, or the premium package, which pretty much includes everything. So there's a bunch of different packages, but of course you can purchase them individually and map them to your own needs as you're going along. So here's an example of a module. We'll be looking at this module. Here's an add-on module, and this is the IBM SPSS tables module, which appears mostly as a single dialog box. There are a couple of other dialog boxes coming, but the main thing is a single dialog box. Is sometimes referred to as simply custom tables, and it's a single dialog box for creating tabulation and reports. It does pretty much all the tabulation that one would require, including the creation of quite complicated tables with very complex or specific formatting that's required. And it has this nice approach where you can preview the table as you drag and drop the fields in, so you can see the table being built up. We'll show a little example of that later on. Suffice to say that that will produce output for you in a range of different formats. These are called table looks. These are little templates that you can attach, come standard with SPSS, but of course you can create your own table looks. And in fact, if you go onto our website again, you'll find that you can download a package of table looks that we have created that sort of enhance the standard tables that you've got there. So these are typical sorts of outputs one would get from SPSS tables. Okay, before we get into the demo, let's just try and focus on 3 things that we need to pay attention to. Okay, so when we think about packages like SPSS Statistics and SPSS Statistics in particular, and we think about people who are particularly proficient in the usage of these sorts of statistical or analytical packages. When you look at where their skills lie, there are usually 3 things that they can do and they can do quite well. And the first thing is that they're usually fairly proficient at reading data, so they know how to get data in various formats, whether it be PDF, whether it be something like an Excel file or a comma-separated file or a database. They know how to bring that data into SPSS. And they know how to format it within SPSS. The second thing is that they're good at transforming and manipulating the data. So that would be, for example, taking something like age, or taking something like date of birth and calculating age from it, or calculating the number of times between 2 dates, the number of days between 2 dates, or merging files, or appending data, or computing a new field, or changing an existing field, from one field type to the next. These are all very important key aspects of playing around, manipulating the data in SPSS Statistics. And certainly in the base version of SPSS, there's a raft of different capabilities that deal with this under the data and transform menus. And the third area, of course, is analysis and deployment of results. So knowing what procedure works well with what particular type of data, or what procedure is going to answer the question that you're asking of the data file. And the deployment of results refers to, of course, putting the results into a format that can be consumed, whether it be a series of predictive scores that you're producing from a predictive model, or whether it be a lot of output or insight that you're generating that you want to then send to PDF or HTML or PowerPoint or something like that. So the key here is it's not all just about stats. It's good to have a little bit of knowledge in these three areas, because that's the way you'll get the most out of the package. And certainly when we do our demonstration, we try to touch on each of these areas. So let's begin by skipping out to SPSS. So this is SPSS Statistics version 25. This is the latest version. And when you open up SPSS Statistics, it looks a little bit like a spreadsheet. That's often a mistake that people make. You shouldn't treat it like a spreadsheet. It's not a spreadsheet at all. This is the window that we're seeing here is the data editor window. This is the data editor window. The data editor window is just a way for us to view the data, for us to see the data. So it's here that we bring data into SPSS. We can have more than one data editor open, and a lot of the default controls of an SPSS, if you're using SPSS currently, for example, you're playing around, but if you go to edit options for here, you'll see that you got all these default controls. So you can have, for example, open one data set at a time. So I'm going to switch that on actually, because it might get a little bit confusing for people who are viewing what I'm doing here if you don't know which data set I'm dealing with. So you can have more than one data set open, but you can overwrite that and say open only one data set at a time. You can also change the default fonts, etc., and how variables and fields are created. And if you want to read data in, of course, you can go to File, Open. It's just like any Windows package. You've got a File menu. You can open a file if you like. So you can open data. You can see that I can open data even from the internet here using the Python enhanced package, which offers the opportunity to enhance your software package by installing a number of Python extensions when you're installing it. So I've done that. So if I go to Open Data here, for example, you can see that the SPSS file type is called an SAV file. But under here, we can see a range of other file types that we can have as well. In the same sense, if I go to File, Import Data, you can see it shows me a list of file types I can read, and I can also connect to a database. And meanwhile, in the other menus, we have standard menus that we would expect, things like the Edit menu, a View menu, and then we get the SPSS specific menus, which are data menus, which allow us to do things to the data file, the Transform menu, which allows us to transform existing variables or create new variables. And then we have the Analysis menu and the Graphs menu. And a couple of extra ones here, such as Utilities, Extensions, which allows us to enhance the SPSS functionality by connecting to the Extension Hub, which is an online hub of different tools that you can install. And these tools are normally based on the R programming language or on Python. And then we have a Windows menu, so very, very traditional Windows application. The key thing to bear in mind here is that there are, in fact, usually two windows that we're concerned about with SPSS. One is the data editor window, which you can see here, and the other one is the output window. And we do spend a lot of our time skipping back and forth between the output and the data editor. They're almost independent applications of one another. One is sitting behind the other, as you can see here. So when we do analysis within SPSS, the results of that analysis is sent to the output window. And as we continue to analyze our data, more analysis is piled up in the output window, and it just keeps on going. And normally what one would do is then one would keep or copy and paste the bits that one wanted to keep or delete the bits one didn't want to keep, and save the entire output window either as in an SPSS output window file called an SPV file, or export it in a format such as Word or PowerPoint or something like that for consumption elsewhere. So let's begin by reading some data in, and we'll assume that we haven't got any native SPSS data to read in here. So if we want to look at, say, reading in data from a database, we can connect to that. And we can say database new query and connect to that. So what's happening here is that under the Microsoft Windows ODBC tool, if you don't know where that is, you can go into, you should be able to click ODBC, and it'll find out ODBC resources, the 64-bit here, but 32-bit. And this is a Windows tool, so it comes with Windows, and it allows us to create connections to databases. So you can see here I've got connection to a SQL Server database. I've also got connections to a couple of Access databases here. So if you have the right to make this connection, if you have the right to set up those connections, and you're allowed to do that, you should find that when you go to File, Import Data, Database, New Query, that you get a link to what's called the database wizard here, and it shows you existing connections that have been set up in Windows. If you don't have the rights to do that, and in fact those rights are maintained by your IT people, or the people who look after the IT systems, or the database managers, then you'll have to ask their permission or ask them to set up these links to your local database for you. And that's quite a common approach that people take. They don't have the right to connect, they don't have the right to set up the link, but they have the right to connect to the data. So for example here, I could connect to a SQL Server database if I click, which is called main. I'll click next here. It just sends a signal to the SQL Server to initiate that connection. And you can see here in the database, I've got lots and lots of different tables within that database. I've got something called here called risk scores, which I can pull across, or I've got something here called loyalty card campaigns you can pull across. I've got education clustering, which you can pull across. So lots of these different tables. In my example here, I'm actually not going to be connecting to SQL Server. I'm going to connect, just because it's probably more common for people, connect to a Microsoft Access database, which isn't a live database. It's just going to allow me to read in an Access database. If I hit next here and browse for an Access database, I should find that there's one in here. You can see that when I do this, it's looking initially for XLS. So you don't see it, but if I switch here to Access, there's one here called employee data.mdb. If I click open at that point, let's see if it works, first of all. Here's the table. It's only a single table. If there were multiple tables, it would join them together for me using a common ID, but I'm bringing the table across and working my way down through the database wizard now. That offers me the opportunity at this stage to limit the number of cases I wish to retrieve. So I could, for example, randomly sample, or I could set up this SQL expression here to limit it. But if I'm happy to read all the data, I can simply say I want to read all the data. It tells me what the field names are going to be when it reads them in. And it even allows me the opportunity to take something like a field here like gender and convert it to a number field, because it's a string type, bar char or a character string variable. And just so you're aware that within statistics applications, we refer to fields as variables. So whenever I use the term variable, I'm really just mean a field. So you can see there's a small number of fields here. I can just read it in using the defaults. It gives me the opportunity to save this as a SQL query, or to save it as a syntax query, an SPSS syntax query. So using one language or the other, i.e. SQL or SPSS syntax. And if you don't know what I mean by syntax, I'll explain that in a second. I hit finish at this point. It goes and queries the database and it reads in the data. Okay, and the data comes in, and the data is raw. So the data is completely raw data here, and it is not formatted in any way. So this is an interesting data set. It's made up of about 474 records, and each record represents an employee within a bank in the US in the 1980s. And the database was used for, or the data set was used in a court case in the US to prove discrimination between employee salaries and employee opportunity. And certainly there's a lot of information in here which allow us to find out and discover some similar discrepancies with regard to payment, etc. But the real reason it's a good database data set to use is because it's got a nice combination of different types of fields, and it's fairly easy to understand. Most people understand this data set because they understand that one row represents every employee. And we have things like gender, their birth date, their age, their education, their job category, their salary, their beginning salary, the time in job, their previous experience, and whether or not they're an ethnic minority employee, and so on and so on. So the key here is that this data set has not been formatted at this stage. If we want to format the data set, you'll notice that very subtly down here we've got what's called the data view, but we've also got a variable view. And when we click on variable view, the fields are now shown in the rows, and we can see the properties associated with the field. So if I just take, for example, a field like gender, let's see what happens if I right-click on this field and I ask for some descriptive statistics. If I do so, it will send results to the output window. And here we have descriptive statistics. You can see it simply says the word gender across the top, because that is the name of the field. And it has the values F and M for female and male, and it's telling me the percentage of male and female employees within the data set. If I click the red star to come back to the data set, what I might want to do is format this field. So I can format this field by going to the variable view tab here and giving it lots of different formatting that we can do. Before we do that, let's read in another version of that data set. So I'm just going to open up another version. So this time I'm going to go open import data, and I'm going to open an Excel version of the data set. So just to show how you would do that. Here's one here called Employee Workbook. It's pretty much the same data set, but this time in an Excel SX format. If I click open at this stage, you can see that now it's a different sort of wizard that's been opened, and it's saying, okay, well, this is what I'm seeing in that data set. Are you happy with that? Do you want me to read the variable names from the first row of data? How do you wish me to determine what type of field it is? So is it a string field? Is it a number field? Is it a date field? So it looks at 95% of the data to determine that. Do you wish me to ignore hidden rows and columns and remove leading and trailing spaces, which I can do, from string data in case there's any leading or trailing spaces? If I click OK at that point, it says, do you want me to save the current data set? I say no. We'll replace it with this new data set. Okay, so now we've got a new data set. As you can see, it's very similar, except we don't have the field age. And again, you have the field gender. And if I run the analysis on gender again, you get the same result as we did beforehand. Here's the new analysis. But slightly different, ever so slightly different here. So we've got 45.7 versus 54.3. There's 475 records in there as opposed to 474. So I'm not quite sure what the difference is, but clearly there's one additional record. Anyway, so let's see what we can do with this field gender. Well, one of the things I can do is I can give it a label rather than simply saying gender across the top. I can give it a nice label, so it says sex of employee. And instead of having the values F and M, I can have what are called value labels attached to that and say the value F should have female and the value M should have male attached to it. Click OK. And now when I run an analysis of it and hit descriptive statistics, you can see that it says down here at the bottom here, it's sex of employee and female and male. So we formatted this field. And if we wanted to make it a little bit wider, we could take the column width here and make it a little bit wider. If I just make it a little bit wider here, you can see it's a little bit wider. Change column width. But alternatively, I can just drag it out here so you can see the whole thing. Notice also that the labels are appearing. This is because within the data editor, we can show value labels. This is the only field that has any labels because it's just been formatted within SPSS Statistics here. So it's the only field. What happens if one of these values is missing? If I just hit delete here, it's missing. You see it's basically a blank now. And if I hit descriptive statistics, you can see it now appears as a legitimate value, but it's just blank. So I could make the blank value and give that a special code. So let's say we put in a code there of X, say that value is missing. In which case, when I come back to the variable view here, I can tell it that X means the data is unknown, so there we don't know the gender. Give it a little label like that. And within the missing values property here, I can add in the value X, and then of course do my quick descriptive statistics analysis again. And it punches out. Now we can see it says male and female in the valid percent column. They're the only two categories that appear, and we have one missing value which is labeled unknown, and that's been taken out of the valid percent. So dealing with unusual and missing values is a good way to us to control that through this variable view tab. Of course, there are many other fields within here, and I'm not going to go through all of them and label them. But suffice to say, if I had already gone through all of them and labeled them, if I had already done that, I could save that formatted file and reuse it again on an ongoing basis to format any new data that's collected in the same file type, if you like. So as new employees are added and that data set is updated and I read it in, I can use my earlier formatted file as a sort of template to format it. So to show you how that's done, I've already created a file, I've already formatted it. I can go to the data menu here and go to copy data properties, and I can browse for an external SPSS data file. Here it is, it's called employee, just the variables. That means it's just got the fields across the top, it's got no cases. It doesn't matter if it has cases, it just doesn't happen to have them. It looks to match the fields by the names. You can see that these fields here in the source data set, this is the data set that we're using to format as our template, already has a number of labels attached to it. Here's our target, our existing data set, and it only has the field names, and hit next here. As we go through this, it's going to attach all of these different properties within the variable view to our current active data set. And we hit finish at the end, you can see it instantly formats the data set for us. And here we have our formatted data set. Maybe even got an extra field up here so where it says unknown. So that's a nice way for us to instantly format our data. If we've already formatted it once, we can just use the existing data set as a template. And you can see here the labels have been attached and missing values have been attached and measurement levels have been set up correctly for us. That means we're able to do some analysis straight away. Okay, so one of the things I might want to do is I might look at something simple like a cross tabulation of job category by gender, let's say. So if I went to do that, if I want to do that, I could go to Analyze Descriptive Statistics, crosstabs, and here we have a crosstabs dialog box. I can make it a little bit smaller, and I can say, yeah, let's put sex of employee in the columns, and we'll put employment category in the rows, and we'll go into the cells here and ask for column percentages so that we're taking percentage off each gender. And we can even ask it to display a little chart for us and click OK. And it produces for us, as you can see, a cross-tab output. Okay, so a cross-tabulated output here showing us that 95% of females are clerical workers, only 4.6% are managers, none of them are custodial. 61% of male workers are clerical, 10% are custodial employees, and 28% are managers. And this, of course, is reflected in our bar chart. Just to be aware that we can actually format and play around with these tables, so we can move things about if we don't like where they appear. We can sort the category orders. We can say, okay, I want to sort by a certain size. We can say, okay, I want to highlight certain values, sort data by certain values. We can really play around with this. We can attach different table looks to it. So if I right click on the table here and right click and say table looks, you can see that it's going to come up with a menu of different table looks. You can say, okay, well, I prefer this one, I want to use that one, and I'll have that. Click OK, it formats it, and we can set this as default, or we can create our own table looks, or we can even, isolate certain values in here and say, okay, well, I want to chart them. So I could right click on these two values and say, just create a little pie chart for me. And it creates a little pie chart for me of those two groups. So you can treat it almost as if it's like a little spreadsheet in and of itself. So there's a lot of things you can do there in the output window, just using a very simple table like crosstabs. What would happen if we wanted to, say, do the same thing with salary? Well, if I right-click here in Descriptive Statistics, one of the clever things that SPSS does is it takes account of the type of field it is. And whereas if I right-click here and say Descriptive Statistics, it gives me a table with percentages in it, because this is a category field. If I do the same thing over here and ask for Descriptive Statistics, it doesn't give me a table of percentages. It gives me some summary measures, the mean, the median, the standard deviation of people's current salaries. You can see 34,000, and it takes it. It's taking account of the fact that it's a number field as opposed to a category field, otherwise known as continuous as opposed to categorical. And if I wanted to do a frequency table of that, it wouldn't work very well because obviously there's an awful lot of individual salaries. When I click OK at that point, it creates a frequency table. As you can see, it's not very useful to me. So I can delete that. Say I don't want that. So how could I represent, what alternative methods have I to represent this data, these types of data? But one thing I can do is I can band these values together into groups. And it turns out that SPSS Statistics have got a very nice procedure to do that, such as visual binning. If I pick on that, it's under the transform menu, and I click on current salary here, click continue. You can see it instantly scans the data for the salary distribution, shows me the salary distribution, and it offers me the opportunity to slice this distribution. So I can cut it and slice it at certain points, and this is done by clicking on Make Cut Points. And I can ask it to, put a cut point at $25,000 and put in 3 cut points, and it will do so for me if I wanted to. Tells me the width is going to be, sorry if I make it 25,000, not 2,500. The width is going to be a certain value here, 4,401.66. Or alternatively, I can say, no, slice it evenly for me using 2 cut points so you break it into thirds, or 3 cut points so you break it into quarters. So I say break it into quarters. It tells me where it's going to slice the data to do that. Here it is at 24,000, 28,000, and 37,050. And if I move these values about, you can see it actually updates the values here. So you can see these values here getting moved about. I'm sliding around. It's taking account of where I'm slicing these. I'll make cut points again, so I'll do it again just to reset that. It says the current ones will be overwritten, and then I could go in here and I could say, well, actually, I just want to round this down so it doesn't say 37,050, but just 37,000. And this one here, I'll round up to 29,000. And this will get me roughly even group sizes. 29,000. No, it's not. It's 2,900. 9,000. There we go. Get me roughly even cut points, and I can say make some labels for these cut points. And I can say this one should be, instead of 37,001 plus, I can just say over 37,000. And if I don't like the less than or equal to, I can say less than or equal to, so I can edit these as I'm going along, of course. And then I can tell it to create a new variable for me called sal band, salary banded. This is current salary binned. I can say grouped if I don't like the term binned. Click OK, and it creates a new field for us. It jumps to the output because it's trying to show us that the log that's created. There's a little log file here. It shows us the procedure that's just run. This is the SPSS Statistics procedure in syntax. And if we go back to the data set, here is our new field that's been created. You can see here, I could edit the salary, the values again, so we get over there, capital V. Change that. And I could say, well, how equal are these? Let's look at descriptive statistics now. Instead of having a big long frequency table showing every individual salary, we've got much more grouped one, and it's it's 25, 24, 24.7. It's nearly equal. This is useful because now I can use this in a procedure like crosstabs, which I did earlier on. And I could say, well, let's look at how salary breaks down by gender, swapping these values around. Click OK, and now we get 48% of females on less than 24,000 compared to 6% of males, 27% on 24 to 29 versus 22% of males, 29,000 16% on 29 to 37,000 compared to 31% of males, and only 7.4% of female employees on over 37,000 as opposed to nearly 40% of males. If we wish to check whether or not this was statistically significant, we can rerun the cross tab again, asking for a statistical test, and the one that's most commonly associated with it is a chi-square test. And if we click OK at that point, it reruns the test, and it gives us a value at the bottom here called the chi-square test, and it tells us the probability that what we're looking at here is in fact a random set of fluctuations, and it tests out the hypothesis that the two variables are effectively independent of each other. In other words, gender has no effect upon your salary. And here we can see that it does have effect upon the salary because there's a very, very small chance, really, that the two are independent. This is the probability value. If you don't know what that means, you can right-click on this, activate this table, right-click on it and say, what's this? And it says, this is a significance level based on an asymptotic distribution of a test statistic. That means an estimated curve. That just means asymptotic distribution means an estimated curve of a test statistic, meaning the chi-square statistic. And it says, typically a value of less than 0.05 is considered significant. So we would say this is a significant relationship here that we're finding between gender and salary. So that's how we would test for significance. What if we wanted to play around with, say, this birth date field here? We want to play around with that and say calculate people's ages. Well, again, if I go to transform and go to a little wizard here, date and time wizard, I can calculate with dates and times. There's lots of different things I can do here, but this is a nice, easy way to do it. And I'd say calculate the number of time units between two dates. And if I take the current date, today's date, minus date of birth, and ask it to return it to me in years, of course, what that is going to do is calculate a field called age today, which would show me what the employee's age is today, not at the time the survey or the data was collected. So if I hit finish here, it's showing what their age is today, and here it is showing the age today at the end. It shows me what that age is. And if I run the descriptive statistics, we can see it ranges from 46 minimum to a maximum of 88. So if we take away some years from that, I don't know exactly when this data set this was run originally, but let's say that the oldest person is 64 or something like that. So if I take away 24 years, I can do that by either overwriting the existing variable or create a new field using the compute command here called age then. I'll call it age then. And I would simply take employee age, and you can see there's a lot of different functions here. I can run very like the sort of functions one would run within Excel, and take away 24 from that, and click OK. That creates a new field for me saying age then. I can take off the decimal places because I don't really need them. There we go. And it shows me age then, and then if I check the descriptive statistics, you can see it ranges from a minimum age of 22 to 64. So we'll assume that's their age. And again, we could band that. I can delete the original age today. We can band that together, or we can use it in scatter plots or analysis and look at the average ages or how age is related to education, etc., etc. So there's a lot of different things we can do there. We haven't looked at filtering the data yet, and we haven't looked at using the charts, and we haven't looked at tables. So let's just quickly do that now. Let us look at, first of all, filtering the data. Let's say that for whatever reason, we are not interested in looking at the management group. Or let's say we're not interested in the custodial group because there's no women in the custodial group. So if I wanted to take out that group and wanted to filter them out, I'd go to data select cases, and I'd set up what's called a conditional select and if condition. And if I can't remember what the code is in any of these dialog boxes, if you can't remember what the code is, you can see the dialog boxes has a lot of little controls. So I can say, show me the variable names, show me the labels, sort them alphabetically, sort them in terms of the file order, or sort them in terms of their level of measurement. And I can also right-click on them and say, show me what's inside the variable, show me the different codes. And sure enough, we can see that custodial has code 2. So if I said, select cases if jobcat is not equal to 2, and click continue, it will filter out everybody in the custodial group. And we'll be able to see that because it creates a new field for us called filter $S. And as we go down through them, you can see that anybody that's in the custodial group is marked with the case header of a stroke through it, a diagonal stroke, to show that they have been filtered out. And of course, we can check it by just doing an analysis here, descriptive statistics. And you can see we only have clerical and managers. So we have 448 cases here, only clerical and managers. So the custodials have been taken out totally. And then if we do some sort of analysis, so for example, let's say that we do a tables analysis, we do the custom tables here. We can say, okay, well, let's look at gender, so we look at sex of employee, and we will break that down by filtered employee category. So I'll put that down there. If I don't want to use the label sex of employee, I can remove that. So I can right click on it and say, yeah, I don't want to use the label. So this is the tables module we're using here. Here we've got the employment category. I can even take out that. I don't want that label there, so it doesn't show. And I can have quite complex tables here. So for example, I could have minority classification across the top, or I could have it, added along the bottom. If I put it across the top here, let's mix it up a little bit. So we'll put minority classification across the top. Are they in the minority group? Yes or no? And we'll add in some continuous fields, such as the current salary, their beginning salary, and their age then, if we like. And we can go here and say, okay, let's look at the totals. So we can put a total in there, which we can rename to base if we like. Hit apply. And we can move where it appears. We can say, well, actually, I want it to go to the top. So it appears at the top, which is quite common in a lot of market research. And I don't want to show means. I say, okay, I don't want to show means. Actually, I want to show the median value. So I've got a control here over that. And I say apply to all and close. And now I've got these tables. And here under count, I don't want count. I'll say I don't want the count being shown. I want to show, what do I want to show? I want to show the row percent, let's say. So I'll put in row percent, add that in. And I'll change the label here. So it's setting row. And so you can see I've got a lot of control over this, and hit apply to selection or apply to all. So here's the row percent been added in. We click OK at that point. We get a table out the back. If we don't like these values here that are appearing, these missing values, you can change that too. Go back here and say, okay, go into options and say statistics that cannot be computed, which means missing, and set the missing here. Click OK. It says missing, and we can change the alignment of values within that, etc., by going into the cell properties and changing the alignment margins and stuff like that. Make it alignment, say apply, or make them all center, and do that. So we've got a lot of control over the formatting, the appearance of the table, and of course, once again, we can control the appearance of it by going into the table properties, if you like, and creating our own table looks. So I could say, okay, I want to create my own custom table look here. And I'll have a very, very dark background. Let's have a very dark sort of teal background here. So that's the color we want. And down the side here, we'll have that color again. And then for the fonts, we'll have maybe a pale, a white color, or something like that across the top there. It's white, right there, white here. And maybe for the values within the fonts here, we can say, okay, well, I want that to be very dark blue. Put that in and hit apply. If you like that, you can keep that and say, well, I want to save this away. I'll actually add a little bit more into it. If I go to table properties here and go to the borders, if I select every border in here and say I want to switch on all of the lines, and I want them to be red, and I want them to be dotted, and hit apply. It will do that for me in the background, and click OK, and it does that in the background, and it gets rid of them for me. And so on and so on. So you can save this out as a default table look at that point, and then reuse it as you wish as you're going along. So there we've looked at the table looks, and we've looked at filtering the data. So here we're filtering the data. Obviously, if I switch off the data filter at this stage and go back to select cases and say select all cases, and then rerun that procedure, it reruns it. But now we've got clerical, custodial, and manager showing up, with just 0% of females. So you can switch these things on and off quite quickly and be quite productive with your filtering and with your slicing and dicing of the data as you're working through it. If we finish up here, just having a look at the charts, we'll go to the graphs menu here, go to the chart builder. And the chart builder up here, for example, allows us to pick charts from a menu. So I've created, for example, a favorite here. If I wanted to create my own favorite, I'll just show you how I did that. I'll say stack this by sex of employee, and I'll put let's put the current salary group there in there, and I'm going to change how it's counting. I'm going to ask for a custom percentage, and say I want the percentage to be based on the total for each category on the x-axis. And then if I like that, I can add these to the favorites menu. I can say add this to favorites, and I'll just call it example because I'll delete it later. And we can add the favorites menu, have it, and see this one here's got different colors associated with it. You can change Could change the chart appearance. So we go in here and change the colors if we wanted. And, use custom colors for these different groups as we go along before we create the table. So, have, oh, I don't want to use pink. I want to use something a bit more neutral. Now let's go for orange and green or something like that, or orange and purple or something like that. So it's very neutral. There we go. Yeah, we'll have that. And chart appearance. We'll go category 2 here. And then click OK. It runs that, as you see, and it produces this chart for us, male, female. And if we wanted to reuse that on a regular basis, this sort of nested chart, we could say, okay, now I want to change that, and I want to use instead of I want to use employment category across the bottom here, rather than sex of employment that runs that. Or we can do some of the things I like to show are things like 95% confidence intervals, which is a way of me showing the error bars. It's a way of me looking at quite rich interactions from the data. So if I look at current salary here, let's look at beginning salary just to make a change here. Broken down by whether or not people are a minority and their gender on the bottom. Instead of just plotting the averages, it's plotting the averages, but showing the 95% confidence interval, so I'm saying that there's a 95% chance that the true average within the population is somewhere between these 2 points. We can see here for the male groups, the confidence intervals are further apart. That is almost certainly due to the fact that there's more variation within the male groups. And we can also see here that for the non-ethnic minorities, for both male and both females, non-ethnic minorities, for the white people basically, they earn more on average, significantly more, because the two intervals don't overlap, than the ethnic minority groups. So it's a way for us to kind of compare these averages and show them visually. I'll just finish up with one last example here. This is called the Graphboard Template Chooser. And this is quite a useful graphing procedure here, where we can click on different variables and it will recommend approaches to us, or recommend charts to us. So you can see here it's saying scatter plot. If I put in 3, you can see here it says, okay, it's offering me a bubble plot or a scatter plot matrix. If I go to the detailed menu here, I can color the bubble sizes by a 3rd variable or a 4th variable. So I'll color them by the same variable the sizes are, which is age then. I click OK at that point. And you can see here, it produces this default template. I should be able to, let me just see if I can click here and say, yeah, if I go to manage, I can use different sorts of style sheets and import different style sheets and different templates as I'm going along. Let me just see if I've got one here, see if it points to one. I think there's a whole bunch. Yeah, there's a whole bunch. But then I've got one here called coffee tea. Let's have a look at that and say import that. Coffee tea style, we'll have that and click OK. Let's see if it makes a difference. Close, click OK. No, it's the same one, sorry. It's obviously, that's the default template we're using. But anyway, look, if I right click on this, if I change the colors, you can get some quite nice charts out of this. So if I go, I'll have this as sort of red color here. You can see, and I can say, let's have the colors solid. And I can also change the transparency level. So I can see the transparency where the bubbles overlap, and I can change the background colors and say I'll have that in a very dark background, slightly less dark background. And I can click on the axes along the bottom here and say, okay, well, I'll have, show me the grid lines for these, major and minor, show grid lines and show ticks. And do the same thing for this axis here, ticks and grid lines. Yeah. And if I don't like the colors, I can change these colors, of course, to gray and stuff like that. Eventually, I can say, okay, I'm happy with that, close it down, and then make a much bigger chart from it. And you get a much nicer chart out of that. So there are some very nice charts you can get. There are other ones one would have, for example, are things like heat maps. I go back here, just quickly show you heat maps. This is when we really want to have a whole bunch of categories, but if I take a current salary by, let's go current salary by age, then by employment category, go for heat map, click OK. You can see here it's showing me where the oldest people are. The oldest people are custodial workers in this salary group here. So it's particularly good when you've got a lot of categories and you want to show the averages across lots of categories, lots of permutations of categories. Anyway, so in the end here, we can take this result here and we can export it, and you can see that we've got lots of different formats. We can export all or export all visible, because there's some invisible items in here that's been hidden. And we can export them as as PowerPoint, as Excel, as HTML, as PDF here, if I put it out as PDF, and I'll just put it out onto the desktop. I'll just put it on the desktop there and say, call it test. Hit save, okay. It should write it out. Let's see if it's writing that out. So it says exporting process, and it's writing all these different charts. So I can do that and then come back to the desktop on my PC. Just go to that. And there's test PDF. You can see it's honored it fairly well. Okay. You can put in page breaks, etc., to make sure it puts them out correctly. You can do exactly the same thing with different types of charts as you're doing on and different types of output and different types of formats. Okay, let's just return to the final slides here so that you're aware of it. So with regard to who we are and working with us, you can buy the software directly from us because we're specialists within this type of software. So you can buy your analytical software directly from us, whether it be SAS or SPSS, IBM or PS solutions. And in fact, you can go directly onto our website and buy it just like any other tool. We also, of course, provide training and consulting services, so that'll be guided consulting and training to help develop your in-house skills, delivery of classroom training courses, and side-by-side training support. We even help with identification and recruitment of analytical skills within your organization, and offer no strings attached advice and support. So technical support you can source directly from us. We'll also offer no strings attached advice. And you can download a 14-day free trial of SPSS Statistics from our website. If you go under our website, you can download the trial and use some of our video materials to help you, get started, as well as the recording of this webinar. You will find that the employee data file, which I was working with, comes with the data set, with the package itself. So it's one of the sample data files in the sample folder that you can use. So if you wanted to recreate or play around with some of the fields and get a feel for how SPSS Statistics works, that would be a good file to use. In the meantime, well, thanks very much for tuning in, and we hope that you'll log in again at some point in the future. Thank you.